God bless you. So we're going to start, this is just kind of a little randomness of all of the different things that we've talked about, okay? The review is much more comprehensive. It's longer, so I'm giving you guys more time to do it. But I just want to kind of review some things from prior that maybe we've forgotten or we could use a little memory jog on. So if I look at number 1 on this Classkick, what do I do with that -3, God bless you, exponent? And we're going to distribute it to everything in the numerator and the denominator. So I'm going to go ahead and rewrite. So I have 2 to the -3rd, x to the what? -9, good. Y to the -6, perfect. And then I have 5 to the -3rd and y to the +12. All right, are we allowed to have negative numbers? Yes, you can have negative numbers in a denominator. Are you allowed to have negative exponents? No. How do I make a negative exponent positive if it's in a numerator? Move it down. How do I make a negative exponent positive if it's in the denominator? You move it up. Okay, so let's just review that. So I'm going to take this and move it down. I have to take this and move it down. I have to take this and move it down. And then I have to take this and move it where? Up. It takes 2 seconds to remind yourself what needs to move where. You're welcome to my color pencils, guys. So when I rewrite this, I have 5 to the 3rd power in the numerator. Is there anything else in my numerator? No. Everything else is in the denominator. So 2 cubed, x to the 9th, y to the 12th, and y to the 6th. Some of you on your quiz just left your answer like this. This is not simplified, guys. You can simplify the numbers and you can combine exponents. So what is 5 to the 3rd power? 125, good. In my denominator, what is 2 cubed? 8. I have x to the 9th and y to the 18th. When we are multiplying same bases, what do we do to our exponents? We add them, okay? Just make sure we remember that. Power to a power, you multiply. When you're multiplying the same bases, you add the exponents. Questions? All right, let's look at the next one. What's the issue here in number 2? There's a radical where? In the denominator. I need that radical to cancel out. How am I going to make that happen? By the conjugate. Perfect. Square root of 15 plus 3. Square root of 15 plus 3. Let's deal with the denominator first, just to make sure that things cancel like they should. So if I have the square root of 15 times the square root of 15, what does that give me? 15. It's the square root of 225, which is 15. So square root of 15 times 3 is plus 3 radical 15. Negative 3 and the radical 15 is minus 3 radical 15. And what's negative 3 times positive 3? Negative 9. Okay, so let's check to see. What happens in the middle with my positive 3 root 15 and negative 1? They cancel, which is exactly what we wanted. And then what is 15 minus 9? Perfect. So did our radical leave the denominator? Yes. Now in the numerator, guys, use your good math skills. When I multiply 2 times the square root of 15, that is not the square root of 30. What is 2 times the square root of 15? 2 radical 15. What is 2 times 3? Plus 6. Now, I am fine with you leaving your problem just like this. In a few weeks or in a week or so, when we get to simplifying complex and stuff like that, you're going to have to simplify stuff like this. But right now, you are fine. If you do this, you're getting points off. That is not the way that you simplify these problems, guys. If you have 2 square root of 15, I'm going to go through this quickly. I don't want to spend too much time on this. We'll show you 2 ways to think about this. In my numerator, what do they have in common? A 2, right? I could factor out a 2, and then I have the square root of 15 plus what? Plus 3 over 6. And then can I simplify here? Yeah, you could write that as the square root of 15 plus 3 over 3. That is the proper way to simplify it. You can also simplify it by writing each of the terms in the numerator, God bless you, over the one term in the denominator. So this would become the square root of 15 over 3 plus 1. These two things are equivalent. They're the same. They're the same as this. But if you just randomly cross off the sixes and make it a 1, you're totally changing the value of the expression. This, and this are all the exact same numerical value. Some of us are still not simplifying correctly because you don't understand, so just leave it like the one in the blue. We're going to go over a whole section of how to simplify fractions and stuff like that when there's multiple things in the numerator and just one denominator. But if you do something incorrectly that is just against like the math rules, you're going to get points off. So if you don't know how to properly do it, don't do it. Does that make sense? You guys okay? Factor completely, yeah.
For the last one, how'd you get 6?
Guys, factor completely. It's not going to give you a list of what to do. You're going to have to be able to factor completely. So what do I look for first? GCF. What is the GCF? Not just a common factor. I want the biggest that they have in common. 4x. Guys, when you take out the 4x, it goes in front of your parenthesis. It doesn't just disappear. So it's 4x, and then what am I left with inside? X cubed minus 125. If that's as far as you get, you've earned yourself about 2 points. Because what is left over here? Not perfect squares, it's cubes, right? So my A term is going to be x. My B term is going to be what? 5. And then we have to know the pattern. So I have my 4x out in front. What does my first parenthesis say? X minus 5, perfect. And then what does my second parenthesis say? X squared plus 5x plus 25, perfect. That is factored completely. Lots and lots of factoring. Look at the next one. It's a trinomial. Is there a GCF? No. Let's check to see if this is a perfect square trinomial. What times what gives me x to the fourth? X squared, x squared. What times what gives me a positive 36? 6 and 6. Okay, so let's check. How do we know if this is a perfect square trinomial? You take x squared times 6 times 2. That's 12x squared. Is this 12x squared? No. So then you're like, oh, wait a second. It's not a perfect square trinomial. So let's try something else. A times C. What are the factors of 36 that are going to multiply to give me 36, but add to give me a negative 13?
9.
What kind of 9? What kind of 4?
Negative 9 and negative.
Perfect. Very good. So what's going to go in the front of each of my parentheses? X squared. Have we factored completely? No. What are you left with? 2 difference of perfect squares. So this becomes x plus 3, x minus 3, x plus 2, and x minus 2. That is factored completely. If they were plus signs in the middle, if it was x squared plus 9 and x squared plus 4, could you factor? No. Good. Good, good, good. We're starting to get that in our brain. I like it. All right, let's look at the next one. What are we doing in this problem? What are we doing? What are we doing? What are we doing? We're multiplying. If we were dividing, what would be the first thing we'd have to do? Keep, change, flip. Okay, good. If we are multiplying rationals, guys, all we're going to do is factor, 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 factor. Find out what they have in common. So I'm going to start with the top left. We're going to do it in blue. What is x squared minus 16 going to become? X plus 4. Good. X minus 4. All right, now I'm going to go to the bottom left. You guys see that color? Yeah. What's x squared plus 8x plus 16? Yep, x plus 4 and x plus 4. That's a perfect square trinomial. All right, so now we're going to go top right. What's the GCF? X. So I'm left with x plus 4. And then we'll go with pink. Bottom right. Take out a 3, and I'm left with x minus 4. Okay, somebody asked me last period, are you allowed to cancel? Guys, think about this. This is just one long division bar. anything in the numerator that's exactly the same as anything in the denominator. It can be right above it, or it can be like a cross. So I have an x plus 4 here in the numerator. Do I have one in the denominator? Yes. I have an x minus 4 here. Do I have one in the denominator? Yes. I have another x plus 4 here. Do I have one in the denominator? Yes. So what am I left with? X over 3. That's it. Take your time. Where you guys will have the biggest issue, I think, is signs. You're going to get careless. You're going to mix up a sign. You're going to forget a negative, something like that. Just take your time. Again, fluency is so important. Go to that review section in modules. It says review of Algebra 1 skills. There's a gajillion factoring problems. Work those. It's very helpful. Like, for example, you had something like this. It has to be 1 to 1. 1 in the numerator, 1 in the denominator. So this would cancel here. Well, let me make this a plus. Hold on. Right, so then one of these will cancel with one of these, but there's still one left over. If there was an extra one up here, they don't cancel because that's not dividing, that's multiplying. Good question. All right, guys. All right, let's look at number 6. Yeah, sorry. When you approach a problem like this, okay, a lot of you had issues when we were adding and subtracting on WebAssign because you didn't do what first? We didn't simplify or factor first. You guys just looked something like this. You're like, okay, the common denominator is x minus 1 quantity cubed times x plus... Guys, if you had this problem, if I gave you 4x over 6 minus 7x squared over 14x, would you multiply 6 and 14x and then try and get a common denominator? No, you guys would say, oh, wait, I can simplify here. This becomes a what? A 2, this becomes a 3. So you have 2x over 3 minus, this becomes a 1, this becomes a 2, that cancels, so then you just have x over 2. And then your common denominator would be what? 6, okay? Same thing goes here. A lot of you on WebAssign just immediately multiplied the denominators together. What did I tell you you should do when you're adding and subtracting, multiplying and dividing rationals? Factor what? Factor first. What can I take out of my numerator on the left-hand side? X squared. I'm going to take out an x squared, and I'm left with what? X minus 1. Okay. And then on the bottom, I'm going to write out all 3 of these, just so you guys see. How many x minus 1s do I have? 3. Okay. Plus, what can I take out of my second fraction? X, and I'm left with a x plus 1. Good. And then on the bottom, I have x plus 1, x minus 1. Now, guys, okay? Yeah.
On the x minus 1? Like x cubed minus 1?
No, that says 3x minus 1s. You can't just distribute over that minus sign. That's saying that you have 3 of those parentheses. Okay. So, guys, look, pay attention to this. Last period kept doing this. Guys, do you see this plus sign here? You cannot cancel like this across a plus sign. You absolutely can't. You can cancel within a fraction, but you cannot cancel across a plus or a minus sign. So in my blue fraction, we can simplify. Yeah.
Shouldn't the bottom right be x minus 1? Like, instead of x plus 1? Oh, no, okay.
Difference of squares?
Yeah.
All I do is just simplify. What can I simplify in the blue fraction? Okay, 1 of the x minus 1. So here is my simplified fraction, x squared over x minus 1 times x minus 1. Then I have a big plus sign, and I can simplify stuff in red. What can I simplify in red? I can cross out an x plus 1. So now I have x over x minus 1. Now, guys, worry about getting a common denominator. But if you do not factor first, you're going to create a huge mess for yourself. Factor first, and you can simplify within that fraction. Not across the minus and plus signs, but within the fraction itself. Like if you had 5/10, you wouldn't leave it as 5/10. You would say it's 1/2. Same exact concept. So now between these two things, what is your common denominator? X minus 1 and x plus 1. Good. Oh, sorry. 2x minus 1. You're right. Sorry. I was thinking about the last one. There's 2 x minus 1s, right? So now we look independently. Look at your first fraction. Your first fraction has Both x minus 1. So do you need to multiply it by anything? No, so you just have x squared. Plus, look at your second fraction. It has one of the x minus 1s. What's it missing? Another one. So what you do to the bottom, you do to the perfect. So, and now we have to simplify. You cannot just cancel out an x minus 1 on the top and the bottom because we have a plus sign here. You've got to simplify the numerator first. So we're going to distribute. You have x squared plus what? Plus what? X squared. And then what? Minus x over x minus 1, x minus 1. I just distributed. And now what can I do with my x squareds? I can combine them. So I have how many x squareds? 2x squared minus x over x minus 1, x minus 1. Now, some of you are going to ask, do I have to simplify more? Personally, I would. What can I take out of the numerator? An x. So 2x minus 1 over x minus 1, x minus 1. Again, I'm going to talk to Ms. Fernandez and Ms. Corey and see how they want it. I think you should factor as much as you can to make sure you're not missing anything that you could cancel. This is my preference, to factor as much as you possibly can to then see, oh, wait a second, I can cancel out something. In this case, can you? No. But when you guys are adding and subtracting, before you get a common denominator, simplify each fraction first. If you can, within that fraction, it makes your life a lot easier. All right, now we come to a problem like this. This seems like cake compared to the last one. What should I do first? I should factor. I'm going to factor this to x plus 2 and x minus 2. Agreed? So here's a big minus sign in the middle here. I can't just start canceling, cross-canceling. I have to find a common denominator. What is my common denominator between x plus 2 and x minus 2? X plus 2 and x minus 2. Good. So look at each fraction independently. My first fraction has the x plus 2 in the denominator. What's it missing? The x minus 2. So we're going to multiply up here. My second fraction has both of them. So do I need to multiply anything? No. So rewrite your numerator, guys. It's x minus 2 times x minus 2 minus 3. That is a minus 3. It's not times negative 3. So you cannot cancel. You have to simplify the numerator. So we have to FOIL. What's x times x? X squared. What's x times negative 2? What's negative 2 times x? Yep, negative 2 and negative 2 is plus 4 and then minus 3. What can I, yes?
I'm confused to why we put the x minus 2 at the top when we're putting it together.
Because you got a common denominator, right? You want your common denominator to look like this. So our common denominator between the two fractions that we have is x plus 2, x minus 2. So that first fraction has the x plus 2. It's missing the x minus 2. So if you multiply it on the bottom, you have to multiply it to the top. What can we combine here, guys? Okay, so I have x squared minus 4x, what? Plus 1. And then what's your denominator? X plus 2, x minus 1. So you guys are going to say, do we have to simplify that more? Yeah, you should.
Wait, how many x minus 1?
It should be 2, sorry. I was about to say, what are the factors of 1 that when you multiply 1, you get negative 4 when you add? Does the top factor? What are the factors of positive 1 that multiply to give you positive 1 and add to give you negative 4? Nothing. Does not factor. But you should always check to see if it does, because if it does, then you're not fully simplified. So check to see if things factor. Do you take out a GCF? Take out the GCF. Do whatever you need to do to factor. All right, one more, and I'm going to let you guys start on the review. This is what we did yesterday. This problem, guys, is just 2 addition and subtraction problems. That's it. And then once you figure out the common denominator and all that, then you can divide them. So let's deal with, I'm going to say the numerator. We're going to deal with I'm going to do this in pieces. So what is my common denominator for what I have circled in blue? 2 times m plus 5. Do you agree? Okay, so let's figure out what each fraction has and what it's missing. So this first fraction, it has a 2. What do I need to multiply it by so it looks like my common denominator? So what you do to the bottom, you do where? Okay. My second fraction has the m plus 5. What is it missing? The 2. So what you do to the bottom, you do to the top. So let's write it out. I have 3m times m plus 5 minus what? 36 times 2, which is 72. Okay, well, I'm still going to deal with, I'm just going to deal right now with just my numerator. I'm just going to simplify everything in one step. So now I'm going to do what with the 3m on the outside? We're going to distribute. So I have 3m squared plus 15m minus 72, right? You guys agree? Okay. I'm still going to worry about simplifying my numerator. Is there a GCF there?
Yes.
Okay, 3. So I'm left with m squared plus 5m minus, good, 24 over 2 times m plus 5. Can I do anything else? Can I factor that trinomial?
A positive.
Yeah. This would become 3. You guys can't see that. This would become 3 times m what? Plus 8? M minus 3 over 2 times m plus 5. All we have done, guys, is simplified the numerator. We added those two rationals together. That's all we've done. We have not done the division part yet. We're going to save that. Now I'm going to work on the denominator. Do the denominator in pink.
Don't we have to put 3 back into the ones in the numerator?
No, not right now. We're simplifying. We're breaking it down. So what is my common denominator, guys, in what I have circled in pink? Yep, 2 times m plus 5. Perfect. So again, look at each piece independently. My first part of my fraction has the m plus 5. What's it missing? The 2. So you multiply the bottom and the top by 2. Agreed? The second piece of my fraction has the 2. What's it missing? The m plus 5. What you do to the bottom, you do to the top. Okay? So I'm going to rewrite. I have 4 times 2, which is 8, minus m times m plus 5. Can I simplify a little bit? Yep. So I have 8. What's negative m times m? Minus m squared. What's negative m times 5? Minus 5m. And then I have over 2 times m plus 5. What's a little bit more that we could do? Okay, write it correctly. So, do you guys want to take out the negative as well? Okay, so I'm going to say negative 1. Then this becomes m squared, what? Plus, God bless you, 5m. Then what? Minus 8. Good. We took out the negative and rewrote it. So that is my denominator simplified. So I'm going to rewrite under here. So I have my problem. If you didn't take out the negative, it's not that big of a deal. I just like to. Have we divided these fractions yet? No, we have not. We've just simplified, at this point right here, all we've done is just simplify the numerator and the denominator. Do I now have them simplified enough that I could do keep, change, flip? Yes or no? Yes. So I'm going to keep this first fraction the same. 3 times m plus 8 times m minus 3 over 2 times m plus 5. I'm going to change my division to multiplication, and I'm going to flip. So this is going to become 2 times m plus 5 over negative m squared plus 5m minus 8. Say it again. We did keep, change, flip. Anything in the numerator and the denominator, that is exactly the same, guys. Yeah, the 2's and the m plus 5's. Good. Does this denominator factor? No. So your final answer to this beautiful problem is that. Now, that problem in itself can be overwhelming. I understand that because there's like 15 things to do. If you try to do everything at one time, you're going to get yourself lost. So go back to where we started and we said, okay, there was a rational adding and subtracting problem in my numerator. There was a rational adding and subtracting problem in my denominator. So we simplified them. We simplified the numerator in blue. We simplified the denominator in pink. And then we did our division. Does that make sense? Kapudi, question or bathroom?
When you like on the last one, aren't you supposed to combine the two? And once you do that, doesn't it become 2 m plus 5 minus m squared plus 5m minus 8? Can't you not take out the 2 m plus 5 because it's being subtracted by a minus m plus or m?
You mean in the blue?
Yeah.
In the blue, since it's all multiplication at that point, you can cancel out anything in the numerator that's exactly the same as the denominator. That's where we canceled out the a and the 2 and the m plus 5's. So there's one in the bottom left and there's one in the top right.
Yeah.
So that they cancel. And then whatever's left over.
Is there gonna be something like this?
Could be. I'm not just doing it for funsies.
How many questions are you doing on the test?
I gotta look.
Like about?
I'll look. I'll pull it up and look.